I'd like to start off this morning by asking you to join me in recognizing the incredible job done by Kathleen, Mario, all the members of the committee, the organizing committee, for putting on such an exceptional event. It's an honor to be here. Truly a job well done. Glassworks is a small business. We're just now coming out of stealth mode. We haven't even published our website for the search engines, so you have to do a little bit of digging to find us. We don't have a long history of contribution to the innovative, transformative history of glass, like most of the folks in this room. We're a startup. However, we endeavor to have our impact on the glass industry and societies and the planet. Glassworks is a tech company focused on advanced materials, and this is our story. We're a close-knit group of like-minded scientists, engineers, system thinkers, problem solvers, and socially responsible entrepreneurs. We collectively have a vision, and the vision is a world without waste. We harness the power of our collective shared vision and commitment to having an impact. We believe that through advanced manufacturing, clean energy, low carbon companies will play a leading role in our immediate economic and societal future. We believe in a triple bottom line. We've got the wrong slideshow, that's okay, I can do it. We believe in a triple net bottom line, which is people, planet, and regenerative economics. Regenerative economics as defined in a new book by John Elkington called Green Swans, a really powerful read. Using technology as a design tool, we find novel and effective ways to design out waste and pollution, upcycle those recovered materials that are diverted from waste streams and landfills. And at Glassworks, appropriately, we are starting with glass. Today's waste streams are a sad legacy of the Industrial Revolution, byproducts of a take, make, and waste. This antiquated philosophy damages and even destroys natural ecosystems that support the very life on this planet. This is literally not sustainable. It's brought us to a point of crisis that we now face, environmental catastrophe and global infrastructure collapse. It's not all doom and gloom. This old linear way of working isn't for anyone or for the planet. The circular economy is one that designs out waste and pollution, keeps products and materials in use, and regenerates ecosystems. Glass in the circular economy. As everyone knows, glass is infinitely recyclable. Despite this, 70% of the glass that goes to our curbside to be recycled still ends up in a landfill. Cities are abandoning their glass recycling programs over profitability concerns. The waste industry's entire economic model is based on pay per ton. It's a hauling industry. It's not a reuse industry. This precious material is being disposed of. We can reverse this trend by making glass easier to upcycle into new materials for a resilient and sustainable future. We can help unlock $4.5 trillion in new economic value by 2030, reduce CO2 emissions by 48%, create quality jobs, improve public health, and heal the planet. The circular economy is estimated to be the biggest economic impact or opportunity in 250 years. I would be remiss if I did not reference the new flagship report released by the UN that just came out Monday. titled, "It's Now or Never." It's now or never by 2030. The circular economy is our shared opportunity. Introducing engineered cellular magmatics. Our founders and scientists have invented a new class of advanced sustainable materials with which we can rebuild resilient cities and societies. They are called engineered cellular magmatics, ECMs. ECMs are restorative and regenerative by design. Through proprietary geomimicry, ECMs can replicate the ability to form priceless geological materials in minutes instead of millennia. ECMs, best of all, are made from post-consumer and industrial waste glass. Our company was formed 2.5 years ago. Our launch was really based on a Department of Energy Advanced Research Project agency that we were a sub-awardee on. It was also our introduction to partnerships that would forever change and drive our focus on furthering this technology. The challenge was to replicate the ancient Roman formula for concrete, a formula that has lasted for over 2,000 years. Seawalls, non-steel reinforced, sitting in the sea, still standing 2,000 years later. The Romans benefited from location. Their rare volcanic tuff that they were able to draw from, which contained some really special materials, Campe Flegrei and Pozzolana Rossae, allowed them to create a concrete that was reactive with its environment and literally became self-healing and restorative. That's why it is still standing today. We successfully replicated synthetically our ancient Roman formula with a new formula derived from ECMs, creating an economical means of making planet-friendly, reactive, ultra-durable concretes that require little or no steel reinforcement, are self-healing through post-pozzolanic mineralization. In the lab, our published results with our partners, the University of Utah, Savannah River National Laboratory, and KMR, showed that we had improved the durability of the ubiquitous ordinary Portland cement, sort of the building block of the industrial civilized world, which has a high-end shelf life of 50 years. We'd increase that durability 4 times. That means we're at 200 years in 2.5 years of research. Also, and of equal importance, we lowered the energy and emissions associated with production and deployment by 85%. A little bit more on that on the next slide. This project is featured in an article in Fortune magazine that was guest edited by Bill Gates. A little bit more on our successes in cement and decarbonization. In Bill Gates' book titled How to Avoid Climate Disaster, he argues the need to get serious about changing the way we produce cement. One of the most ubiquitous construction materials is also responsible for 6% of all carbon emissions globally. I've seen other stats that have it as high as 8% of all carbon emissions globally. In our Roman project, we saw a pathway to lowering CO2 emissions from introducing new cementitious materials, or lightweight ECM formulations, to ordinary Portland cement, supplementing as a sweetener, if you will, allowing us to lower acquisition costs, no mined aggregates, less CO2, lower production costs, less clinker, less CO2, lower distribution and transport costs, fewer trips, less CO2. 3 trucks of our ECMs is equal to 1 truck of mined aggregates. More efficient on the transportation side. greater durability and longevity, less CO2. ECMs are valuable. We see applications in two specific areas: gray infrastructure, seawalls, dams, bridges. Blue-green infrastructure, think air, water, soil remediation. On the gray infrastructure side, I just gave you an example of what we intend to take to market and pilot. Our reactive seawater concrete seawalls, of which it's estimated the US alone needs 50,000 miles of, on our coastal cities to combat sea level rise. That's twice around the Earth. On the blue-green infrastructure side, we lean on our partner at Savannah River National Laboratory, again, a great partner they have been, where they're currently helping us to drive research and further driving their own research and using ECMs as a delivery vehicle for bioremediation of hydrocarbons and heavy metals. ECMs and their infinite tailorability make them an excellent platform for focusing on both strength and durability, but also as a habitat for microorganisms where we can create infused nutrient sources that enables colonization and growth. We believe in Industry 4.0. I also believe in Industry 5.0. I believe in the human element to all technological innovation. Today, our prototype facility upcycles post-consumer waste glass, saving upwards of 38 to 43% of the embodied energy cost over raw mined materials. As the world moves to globally sustainability, we are developing new materials and new methods that are carbon neutral with significantly lower embodied energy costs. Our proprietary AI, a physics-driven machine learning platform developed by Dr. Colin Wilkinson, who will be speaking here in a couple hours, allows us to engineer unique and economical ECMs in radically faster development cycles. We're also engineering unique purpose-built kilns and furnaces that monitor, optimize production, reduce energy consumption, utilizing the industrial Internet of Things, which allows our facilities to potentially be a local energy producer and return power to the local grids. Beyond recovered glass, as the world moves towards sustainability, recovered glass will become a desirable commodity across industries. With the assistance of the Department of Energy and our good partner, Savannah River National Laboratory, we now know that we can create ECMs out of municipal solid waste incinerator residue, ash. How can we do this? A lot of glass goes into those waste energy plants. It's a high silica content that allows us to use this too as a base material. Ash is abundant, and today waste energy facilities pay a premium to landfill these residues, so there's a negative market for these materials. What else can go into an ECM? ECMs can utilize various building and construction waste as secondary inputs. We have successfully upcycled industrial waste materials from Corning, Boeing, and Covanta to create highly performant ECMs. In the case of Boeing and their 777 manufacturing plant in Charleston, South Carolina, we're taking their carbon fiber dust residue and actually using that as a material input into a potential filtration ECM application. We've already created ECMs out of utilizing mine tailings. ECMs can help create resilient cities through gray infrastructure applications and blue infrastructure applications. We see ECMs playing a significant role in the future, helping not just add resiliency to cities, but resilient cities equal resilient societies. Beyond ECMs, we're looking into Unique substrates that underscore the value and practicality of advanced geomimicry and its place in the design thinking toolset of the circular economy. While ECMs have demonstrated and hold immense promise, we believe there are even greater revelations on the horizon, new substrates born of geomimicry, and an overwhelming need to further address climate change, decarbonization, environmental remediation, sustainability engineering, and circular economics. This is my favorite slide. Not because we're almost done. We partner with some of the biggest, brightest minds, most forward-thinking companies across government, industry, and nonprofit. ECMs would not exist today and would not have been brought to market at this incredible pace without the help and dedication of our partners at SRNL, the Department of Energy's Advanced Research Project Agency, Pennsylvania State University, KMR, and Lucas Engineering, amongst others. These partners have allowed our internal team, Rob Husker, Nielsen, Dr. Colin Wilkinson, and others, to recruit incredible talent and to benefit from the work and insights of doctors like Vahid Majidi, the director of Savannah River National Laboratory. I hope you're still here, Vahid. Vahid is a trailblazer in every sense of the word. He took over the national lab and is enabling its transition from a mission of weapons to science. His continued commitment to furthering the research of ECM technology is driving new frontiers from gray infrastructure, sustainable, reactive, ultra-durable, lightweight concretes, environmentally beneficial bioremediation technologies. We literally thank you, and every day we thank you for our relationship with you, Dr. Majidi, and the National Lab. Dr. Corey Tribblepiece, whose mentor was Dr. Carlo Pantano, is our primary point of contact and one of the primary innovators in the space of ECMs through the lab-directed research and development projects at SRNL. Dr. Tribblepiece is helping us forge new pathways to what is possible with ECMs and beyond. Dr. Carol Jansen, who's a former president of this esteemed body, and I believe she was the first woman president, if I'm not mistaken, has been a trailblazer for us as well. Dr. Robin Brigman, Dr. Gene Ramsey, Dr. John Morrow, and the engineering expertise of Thomas Adams, who we met through the Advanced Research Project Agency at Energy. We believe in collaborative innovation. We like it when really smart people get together, are dedicated on a common purpose, having an impact. I'm here today to ask you, will you partner with us too? To Corning, to Owens, Illinois, to Schott, to the glass industry, MoSci. We want your waste. It's a value, extraordinary value. Let's upcycle it and turn it into products and materials that can bring resiliency and sustainability to the country and to the world. To researchers and universities, partner with us. Explore what can be possible. Let your students, your interns, turn them loose. We will support those efforts. We look forward to an opportunity to working with you. And I wouldn't be an entrepreneur if I didn't say, and if you're interested in strategic investment, we are a startup, so we are always looking for money to help really bring about bringing a technology to the forefront that we know is proving itself to have great potential. Final note. I'm the co-founder of a company called Glassworks, but I didn't know enough about glass, I realized, having sat through the incredible presentations of the last couple of days, the societal impact that glass has had. I believe this body, this industry has a very unique opportunity. I believe you have an opportunity, we have an opportunity to become the de facto standard of the circular economy. The history supports it. The level of innovation and transformation supports it. Once we all embrace that glass is infinitely recyclable, we won't let it be thrown in the ground anymore. We'll continually look at reuse, regeneration, becoming the feed, the model for the world as an industry on the circular economy. And as the UN said, if not now, never. Thank you very much.